Okay, I'm trying to explain polarity because it's fairly complicated and adds more room for miscommunication and misunderstanding. And if we all spoke the same language in how we talk about polarity, things would be a whole lot easier, right? So let's start with the top, right? When you buy a new piece of fiber off the shelf, it's going to have what's known as a native cross, meaning that TX will go to RX and TX will go to RX on both ends, right? One side of the fiber transmits, the other end listens. One side transmits, the other end listens. And if we have a more realistic example here, we will see on a known good fiber connection, this is non-polarity mismatch, this is the same piece of fiber too. Do you see how there's a bit of gray on top on both ends, right? That is a quick visual indicator to show you that the polarity on both ends of these fibers is adequate and has maintained its native cross, right? So gray and gray, or black and black, right? I like to keep it simple. I like to make one of them. I like to choose a color and make sure that every single connection is the same. It's all gray or it's all black, right? But of course, different people and different companies do different things and have different codes. But what happens when one end of it is twisted? We will have this cable here. Do you see how the top of the one on the left is black and the top on the one on the right is gray? That means that the native cross within the cable, we're not talking patch paneling yet, we're not talking crossing between links, we're not talking about that. We're talking about the native crossing, the native twisting within the cable itself is now nullified because you have homogeneous colors. Or I'm sorry, you don't have homogeneous, you have opposite colors. You want homogeneous colors of gray and gray, black and black, but you have gray on one end, black on the other end, which means that the TX that should be going to the other side's RX is now going to the other side's TX. So it's transmitting on the same line as it's transmitting, as traffic is coming from and it's going to. It's colliding in the middle and it's listening on both ends, so it's not hearing anything. At this point, if everything else is normal, if you have, and this is what's really important to really illustrate, because I wanted to draw this diagram and I'll get to it soon. If you have a patch panel, right? Fiber, fiber, fiber. And the color coding here is black and black. And the color coding here is black and black on both ends, just like you have here, right? But then on one end it's black, but on this end it's gray. You then have what's known as a polarity issue because it's crossed on one end. There are ways to fix this. To be completely honest, there's a very quick and dirty way to fix this. And the quick and dirty way to fix it is to make one of these gray. You can fix this side, but that would make you, that would force you to do work, chase it down, find out which end has the wrong color or the wrong polarity and fix it. And that is just too much work. So you can just do that, but here's an issue. When this short piece of fiber, because it usually goes short, or it usually goes like optic, switch, right? And then optic, and then switch, and then short run fiber, long run fiber, long run fiber, short run fiber. When this piece of fiber here gets replaced, it's gonna be replaced with an off-the-shelf native cross, black, black, gray, gray, right? So then it's gonna take your fix and revert it to black, black, or it's gonna take your fix and revert it to gray, gray. And now you're not gonna have any data go through here because you didn't fix it here originally. So for overall, data center hygiene, you wanna make sure that you have homogenized colors on every single end of it because of that. And there's special software in certain places that allow you to track this so that way you don't run into random polarity issues. Now, one issue that you could be seeing is that company A deploys a short, company A deploys a short, but then company B was in charge of deploying the long run fiber, and they threw in whatever they wanted and didn't care, or didn't have any standards or whatever, or you're inheriting a place and God knows what happened to it for the past 10 years. And for whatever reason, the signal's not going through. No matter what you do, you replace the switch here, you replace the optic here, you replace the switch here, you replace the optic here, you loop back it comes up, you know this place is good, you loop back the optic here, you know it comes up, like it's all good, but it's actually this gremlin up here that no one is checking and no one looking for, which is known as polarity. Now, like I said, there's a quick and dirty fix, but it will screw you over in the future because of the fact that you didn't fix it the right way. Now, polarity is interesting because it has what's known as the sort of, I'm calling it the rule of squares, right? But it's kind of like this. If you have your native cross, if your cross is native, you're going to call that 0. But if you have a cross or a twist or polarity, twisting, whatever, that's more than native cross, you have an odd number of crosses, right? You need to change that by turning that into 2, or an even number, where it's your native plus 1 plus another one of them, right? Which is what you're doing here. You had your native, then you had the original crossing up here, right? So to fix that, you make another cross, therefore 2 crosses, native plus 1 cross plus another cross, to allow traffic to go through, right? Now I can map it out and show TX is going RX and TX is going RX, but essentially the fix is to make this an even number. And it doesn't matter if you have like a million patch panels, as long as the number, like if you have 11 patch, like if you have 11 crosses, because it's like native plus 1 plus, you know, ad infinitive, all you have to do is make it 12 and the link will come up and completely fix polarity. I guarantee you that that's the case, but it's not an adequate way of planning and, you know, having general health and longevity.